Joint variation examples and word problems. Some of the examples of writing a joint variation equation. So first we have y is equal to k, which is the constant of variation. Multiply that by x and z. So one variable and two variables. There is also the y is equal to the constant of variation, which is k. Multiply that by x and z squared. And we also have y is equal to k and k multiplied by w multiplied by x and multiplied by z. So in these examples, the letters w, x, y, and z, okay, they are all variables or numbers. So they are all variables or numbers. And then we have the letter k. So the letter k, here, this is the constant of variation. So again, y equals to k x z, y is equal to k x z squared, and y is equal to k w x z are some of the equations for joint variation. Okay, so we have here some statements. We will convert them to joint variation statements or mathematical statements. So our first statement, y varies jointly as x and z. So to translate this, our first statement is y. So the first variable here, which is y, this is written on the left side. So y is equal to, so the word jointly, this means that our equation is a joint variation. So we are going to put the constant of proportional or constant of variation, so this will be equals to k. And then as x and z, so y is equal to k and x and z, so k multiplied by x and z. So the first variable, which varies as the two variables, so the first variable is written on the left side, and the two variables that varies, they are written on the right side. Okay. Example number 2, y varies jointly as x and the square of z. So our first variable y, which varies jointly, so this is written on the left side, equals to, again, do not forget the constant of variation, which is k, and then k will be multiplied by the two variables that varies with y. So the two variables are x, so this will be k times x, and the other is the square of z. So this will be z raised to the power of 2. So y varies jointly as x and the square of z. Its translation is y is equal to k times x times z squared. Our third example, y varies jointly as w, x, and z. Okay, so y here, this is the variable that varies. So since it is the variable that varies, it will be on the left side, equals to, again, do not forget the constant of variation, that is letter k. So k will be multiplied by the variables that varies with y. So the variables that vary with y, we have w. So this will be k times w, and we also have x. So w times x, and lastly we have z, so times z. Okay, so y varies jointly as w, x, and z. It is written as y is equal to k times w times x times z. Translate into mathematical equation. Problem number 1. The area, or A, of a rectangle varies jointly as its length L and width. We are now going to translate into mathematical equation real-life variables. So our first here, the area A, okay, varies jointly. So since it is the one variable that varies jointly, this will be on the left side. So we have here A is equal to, it varies jointly as its length L and width. Okay, so after writing the variable on the left side, do not forget the constant of variation, which is k, and then the constant of variation will be multiplied by the two variables that varies jointly with the area. The two variables that varies jointly with the area are the length, which is L. So this will be k times L, and the width, which is represented by W. So this will be k times L times W. So our mathematical equation now is A is equal to k times L times W. Problem number 2. Force varies jointly as the mass m and acceleration. Okay. So our variable on the left side will be the force, since it is the one that varies jointly with the mass and acceleration. So force here is represented by letter F equals to, do not forget the constant of variation, that is letter K, and multiply K by the variables that varies with force. The variables that varies with force, we have M, so this will be K times M, and acceleration, that is letter A, so K times M times A. So our mathematical equation now is force is equal to, or rather F is equal to K times M times A. Problem number 3. The area of a triangle varies jointly as the base and height. So the area of a rectangle, so the area here, or the area rather of a triangle, varies jointly. So it is the one variable that varies jointly with the two variables. So we are going to write on the left side the area that is represented by A. So A is equal to, again, do not forget the constant of variation, that is letter K. So K will be multiplied by the two variables that varies with the area of the triangle. The two variables that varies, we have the base, So this will be represented by the letter B and the height, which is letter H. Our mathematical equation now is A is equal to K times B times H. Joint variation word problems. Problem number 1. If A varies jointly as B and C, and A equals to 30, when B equals to 5, and C equals to 3, find A when B equals to 6 and C equals to 8. So we have three variables, variable A, variable B, and variable C. And then we have two sets of values for A, B, and C. So the first value for A, as stated on the problem, if A equals to 30. So A here is equal to 30. When B is equal to 5, so B is equal to 5. And C is equal to 3. So these are the initial values or the first values of A, B, and C. So we need to write the joint variation equation, and that is A would be equal to, so since A is the variable that varies jointly as B and C, so A is on the left side. And then we have the constant of variation. Okay, let's change the color of K. So the constant of variation, this is K, and then multiply this by the two variables that vary with A. So K will be multiplied by B and C. We need to find the value of K. So substituting the values, we have A that is equal to 30 equals to the constant of variation times B, which is 5, multiplied by C, which is 3. So 30 will be equal to K times 5 times 3, that is 15. So to find for the value of K, we need to cancel out 15. To cancel out 15, just divide both sides of the equation by 15. So we have here 30 times 1 over 5, or rather 1 over 15, that will be 30 divided by 15 equals to, so K times 15 times 1 over 15, this will be equal to K, since 15 divided by 15 is 1. So our K here is equal to 30 divided by 15, 2. Okay. We have the value for K. Now, let us know the second values of A, B, and C. Okay, so next, let's continue to read the sentence. Find A. So, meaning to say that A here will be the unknown when B is equal to 6. So, B here is 6, and C is equal to 8. So on the succeeding statement, A is our unknown, so we have to find for the value of A. Again, we will use the equation A is equal to K times B times C. So we now know the value of K. So to find for A, we will just substitute the value of K, that is 2, and then multiply this by the value of B and C. So our B is 6 multiplied by the value of C, which is 8. So we have here A will be equal to 2 times 6 times 8, and that will give us 96. So the value for A here is equal to 96. Problem number 2. The area or A of a triangle varies jointly as its base and height h. If its base is 8 inches and height is 7 inches, it has an area of 28 square inches. Find the base if its height is 5 inches and its area is 16 square inches. So we have three variables given. So our first variable is the area, or A. So this is A here. And the second variable is the base, or B. The third variable is the height, or H. So the value for base is 8 inches. So B will be equal to 8. And the value for height is 7 inches. And the area is 28 square inches. Okay, so using the values of these three variables, we are going to find for the value of K. So we know that the joint variation equation for this will be A is equal to, since A varies jointly with its base and height, so our equation will be A is equal to K, which is the constant of variation, multiply that by the base and the height. A is equal to 28 equals to K. Our B is 8 and our height is 7. So 28 is equal to K, and 8 times 7, that is 56. So to find 4K, we need to cancel out 56. So divide both sides of the equation by 56. So our K now will be equal to 28 all over 56, or this is equal to 0.5. We now have the value for K. So let us continue to read the second sentence. Find the base. Okay, so we have to find the base. So the second value here for base is an unknown. So B here will be our unknown. If its height is 5 inches, so our H, the second value for H is 5. And its area, so we have here a second value for area, which is 16. So given the value for A, which is 16, and the value for H equals to 5, and the value of K, which is 0.5, we can now find the value for B. Again, we are going to use the equation A is equal to K times B times H. Okay, so to find for B, we need to transpose K and H to the other side. So to do this, divide both sides of the equation by K and H. So B now will be equal to, okay, A all over KH. And our A is equal to 16 divided by K, which is 0.5, and multiply this by H, which is equal to 5. So our B now, or our base, that will be 16 divided by 0.5 times 5. So we have 6.4. So 6.4, or B equals to 6.4, is our final answer for number 2. Number 3, the kinetic energy, or KE, varies jointly with mass and the square of its velocity. The KE is 3,300 joules when the mass is 66 kilograms and velocity is 5 meters per second. Find the KE, or kinetic energy, when mass is 75 kilograms and velocity is 7 meters per second. Okay, so basing on the problem, we have the given, the kinetic energy, and it varies jointly. So KE will be on the left side later of our equation. So KE here is one of the given. Another given is mass, and the other given is the square of velocity. So KE here, the KE is 3,300. So 3,300. And then the next given is the mass, which is 66. So M here will be 66. And the third given is velocity. So the V here is 5. Okay, let us make our equation for this. So the KE varies jointly. So KE will be equal to, it varies jointly with mass. Okay, but first do not forget the constant of variation. So KE will be equal to K, and this will be multiplied by the mass, which is M, and the square. Okay, take note, the square of its velocity. So this will be V raised to the power of 2. Okay, so this is our equation. We can now find for the value of K. Our KE is 3,300 equals to K. Our mass is 66 and our V is 5, but this will be raised to the power of 2. So 3,300 equals to K times, okay, so that will now be 66 multiplied by 5 raised to 2 is 25. So that is K times 1,650. So to find for K, we need to cancel out 1,650. So to do that, just divide both sides of the equation by 1,650. So our K now, the value for K will be 3,300 divided by 1,650. So our K here will be equal to 3,300 divided by 1,650. That will give us 2. So our K, or the constant of variation, is 2. Let us now continue reading the problem. Find the KE. So we have to find the second value for KE. So since we have to find the value for KE, on our next statement, the KE is the unknown when mass is 75. So M here will be equal to 75 and velocity is 7. So V is equal to 7. And to solve for KE, we have to use the same equation. So our equation will be KE is equal to K times M times V squared. So KE will be equal to, the value for K is 2. And multiply this by M, which is 75. And our V is 7, but that is raised to the power of 2. So KE now will be equal to, so 2 times 75 times 7 raised to the power of 2, and that will give us 7,350, and the unit is in joules. So KE equals to 7,350 joules is our final answer for problem number 3. Inverse variation, finding the values of x and y. Problem number 1. Y varies inversely as x and y equals to 9 when x is equal to 4. Find y when x is equal to 6. The first value of y is 9 when x is equal to 4. Our equation for this will be based on the sentence. So x, or rather y, varies inversely as x. Our equation will be y multiplied by x equals to the constant of proportionality, which is k. Our y is 9 multiplied by x, which is 4, equals to k. So our k will be equals to 9 times 4, that's 36. Our second value for y. So our y here is an unknown since we are going to find for y. So y here is the unknown when x is equal to 6. We are going to use the same equation, and that is y x is equal to k. Our y is unknown and our x is 6, so that is 6y equals to, our k is 36. To find for y, we need to cancel out 6. To cancel out 6, just divide both sides of the equation by 6. So this will be 6y times 1 over 6. That is 6y divided by 6. And 36 times 1 over 6, we have 36 all over 6. 6 divided by 6, this is 1. And 1 times y, this is equal to y. 36 divided by 6 is 6. Y is equal to 6 when x is equal to 6. Problem number 2. Y varies inversely as x and y equals to negative 8 when x is equal to 2. Find y when x is equal to 4. So the first value of y is negative 8. And the value for x is equal to 2. Our equation will be, so it is y varies inversely as x. So the equation will be y times x equals to k. So the value for y is negative 8 and the value of x is positive 2. This is equal to k. So our k here will be equal to negative 16. And then we will find for the second value of y. So the second value of y is unknown. So y here will be the unknown when x is equal to 4. Again, we are going to use the same equation, that is yx is equal to k. Our y is unknown, but our x is 4. So 4y equals to k, which is negative 16. So to find for y, we need to cancel out 4. To cancel out 4, just divide both sides of the equation by 4. So we have 4y multiplied by 1 over 4, that will be 4y divided by 4, and negative 16 times 1 over 4, that will be negative 16 all over 4. So 4 divided by 4, so 4 divided by 4, that is equal to 1. And y now, so y will be equal to negative 16 divided by 4, that is equal to negative 4. So our y is equal to negative 4 when x is equal to positive 4. Number 3. Y varies inversely as the square of x, and y equals to 8 when x is equal to 3. Find y when x is equal to 12. So the first value of y is positive 8. And the first value of x is positive 3. Our equation will be, it is y, which varies inversely as the square of x. So our equation will be y multiplied by the square of x. And that is equal to the constant of proportionality. So we have y, that is 8, and our x is, okay, so our x here is 3. So x there will be 3 raised to the power of 2 equals to k. So 8 multiplied by 9 equals to k. So our k here will be 72. And now for the second values of y and x. So again, we are going to find for y. So this will be, y is the unknown when x is equal to 12. We will use the same equation, and that is y multiplied by x squared equals to k. Our y is the unknown, and our x will be 12 raised to 2 equals to k, which is 72. So we have 12 multiplied by 12, or 12 raised to 2, that will give us 144. Y equals to 72. So to find for y, we need to cancel out 144. Just divide both sides of the equation by 144. So we have here 144y all over 144 equals to 72 all over 144. So 144 divided by 144 is 1. So 1 times y, that is equal to y, and 72 divided by 144 is 0.5. So our y here is equal to 0.5 when x is equal to 12. Problem number 4. A varies inversely as the square of b, and a is equal to 9 when b is equal to 8. Find a when b is 4. The first value for y. So the first value for y, or rather a, the first value for a is 9 when b is equal to 8. Our equation will be based on the problem, and that is a varies inversely as the square of b. So our equation will be a multiplied by the square of b, so that is a times b squared equals to the constant of proportionality, which is k. So our a here is 9 multiplied by b, which is 8, and that is raised to the power of 2 equals to k. So 9 times 8 raised to 2 is 64 equals to k. So our k here will be equal to 9 times 64, that will give us 576. So k is equal to 576. Let us now find the second value for a and b. So our a here will be, since we need to find for a, so we have to find for a, our a here is the unknown when b is equal to 4. We will use the same equation, and that equation is a multiplied by b squared equals to k. Our a is the unknown, and our b is 4. So this will be 4a equals to k, which is 576. Okay, so let's check. So this is 4 raised to the power of 2, since it is b squared. Okay, so again, let's explain this one. So our a is the unknown, and b squared will be 4 raised to the power of 2 equals to the value of k, which is 576. So 4 raised to 2 is 16. So we have here 16a equals to 576. To find for a, we need to cancel out 16. So divide both sides of the equation by 16. So this will be 16a times 1 over 16. That is 16a all over 16. And 576 times 1 over 16, that will be 576 divided by 16. So 16 divided by 16. This will be equal to 1. So 1 times A is A. So this will be A equals 2. And we have 576 divided by 16. That will give us positive 36. So our A here is equal to positive 36 when B is equal to 4. Problem number 5. P varies inversely as Q and P equals to 2 when Q equals to 12. Find P when Q is positive 6. So the first value for P and Q. P is equal to 2 when Q is equal to 12. So our equation will be based on the problem, and that is P varies inversely as Q. So we will have here P multiplied by Q equals to the constant of proportionality, which is K. So our P is 2 multiplied by Q, which is 12. And this is equal to K. So our K here will be 2 times 12, that is 24. And the second values of P and Q. So we need to find P. So our P here is the unknown. And our Q is 6. We are going to use the same equation. So our equation will be PQ equals to K. Our P is the unknown and our Q is 6. So 6P equals to K, which is 24. So to find for the value of P, we need to cancel out 6. So to cancel out 6, just divide both sides of the equation by 6. So we have 6P times 1 over 6. That will be 6P all over 6. And this will be 24 times 1 over 6. That's 24 divided by 6. So 6 divided by 6, that is equal to 1. So we have here 1 times P, that is P. 24 divided by 6 is 4. So P is equal to 4 when Q is equal to 6. Inverse variation word problems. Problem number 1. The number of hours constructing a deep well is inversely proportional as the number of men doing it. It takes 10 hours for 2 men to construct. How many men are needed if they need to finish it in 4 hours? First, we are going to represent by Y the number of men. So Y will be the number of men. And then we are going to represent by X the number of hours. So the initial value of Y and X is that it takes 10 hours for 2 men. So Y here will be equal to 10, while X is equal to 2. Okay, so we are then going to find for the constant of proportionality, or K. Our equation will be Y multiplied by X equals to K. Our Y is 10. Multiply this by 2. So 10 times 2 is the value for K, and that is 20. We will then find for the second values of Y and X. How many men are needed? So the number of men, or the second value for Y, is the unknown. So this will be represented by the question mark. So our Y here is the unknown when X is equal to 4, or 4 hours. So to find for Y, we will use the same equation, which is Y multiplied by X equals to K. Our Y is the unknown and our X is 4. So this will be 4Y. and our constant of proportionality is 20. To find for y, we need to cancel out 4. So to cancel out 4, divide both sides of the equation by 4. This will be 4y multiplied by 1 over 4, that is 4y all over 4. And this will be 20 times 1 over 4, that is 20 divided by 4. So we have here 4 divided by 4, that is equal to 1. And 1 multiplied by y, that will give us y. 20 divided by 4 is 5. So our y here is 5 men. So 5 men are needed to finish constructing the deep well within 4 hours. Problem number 2. When riding a bus at 55 kilometers per hour average speed, it takes Marcel 3 hours to reach his destination. How long will it take him if he travels by van at 670 kilometers per hour? Okay, so first we need to represent as y the number of, or the average speed. So y will be equal to the average speed. And then x will be the number of hours. So this will be the number of hours. So we will get the initial values of y and x. So in the problem, it states that it takes Marcel 3 hours to reach his destination at an average speed of 55 kilometers per hour. So our y here, our equation rather, will be y multiplied by x equals 2k, since this is an inverse variation problem. So the value for y now will be the first average speed, and that is 55. Multiply this by x, or the number of hours, and that is 3 hours, equals to k. Okay, so that you won't get lost, we will put here y is equal to 55 when x is equal to 3. Okay, so let us continue. The constant of proportionality now will be 55 multiplied by 3, that will give us 165. And then we will find the second values of y and x. So continuing reading the problem, we have how long will it take. So how long, this means that the value for y, or the value for x here, is the unknown. So our x will be the unknown, and our y will be equal to 70 kilometers per hour. There. So how do we find for x? Again, we will use the equation y multiplied by x equals to k. Our y is 70 and our x is the unknown. Our k is 165. So to find for x, we have to cancel out 70. So to cancel out 70, divide both sides of the equation by 70. So 70x times 1 over 70, that will be 70x all over 70. And we have 165 times 1 over 70, that will be 165 divided by 70. Now 70 divided by 70, that is equal to 1. So 1 multiplied by x, that will be equal to x. And 165 divided by 70, that will be equal to 2.36. And our unit here will be the number of hours. So it will take 2.36 hours, okay, if Marcel will travel at 70 kilometers per hour. Problem number 3. A group of 10 men decided to rent a house for $100 for 1 week stay. But 2 of them got sick and could no longer join. How much would each man pay for the rent? First, we need to, so we need to have y and x. So our y here will be the group of men, the number of men. And our x will be the contribution or the payment of each man. Payment of each man. Okay, so let us first find the y and x, or the first values of y and x. On our sentence, a group of 10 men, so there are 10 men. The y here, the first value for y will be 10. And then rent a house for $100 for 1 week stay. Now, how are we going to find for x? So to find for x, since it is $100 divided by 10 men, so this will be 100 all over 10. So our x here is $10. So we need to solve for the value of k, or the constant of proportionality. So our equation, since they are inversely proportional, this will be y multiplied by x equals to k. Our y is 10. Multiply that by x, which is also 10. So this will be 10 times 10 equals to k. So our constant of proportionality will be 100. And then we will find for the second values of y and x. Okay. 2 of them got sick and could no longer join. So this means that our y here will be the 10 men minus 2 who got sick. This will be 8. And the second value for x, how much would each man pay? So this means that x here, or the amount of payment of each man, is unknown. So this will now be the unknown. So let us find for the value of x. Again, our equation will be y multiplied by x equals to k. Our unknown is x, and the value for y is 8. Our k is 100. Now, to find for x, again, we need to cancel out 8. So to cancel out 8, divide both sides of the equation by 8. So this will be 8x times 1 over 8. That will be 8x all over 8. And this will be 100 times 1 over 8. That is 100 divided by 8. So 8 divided by 8, that is equal to 1. So 1 times x, that is equal to x. And we have 100 divided by 8. That will give us 12.5. So since x is the payment of each man, so this will be $12.5. So this is the payment of each man for the rent. So each man will pay. So x is equal to $12.5 is our final answer. Problem number 4. Clark on his first drive traveled from home to his destination for 6 hours with an average speed of 60 kilometers per hour. What should be his average speed if he wants to get there within 5 hours? So first, we need to represent y as the number of hours. Okay, so this will be the number of hours. And we need to represent x as the average speed. So the initial values of y and x, so our y is equal to 6 hours, so this will be 6, and that is 6 when x is equal to 60 kilometers per hour, so this will be 60. Okay, so we need to find the constant of proportionality, or k. Our equation will be yx is equal to k. Our y is 6 multiplied by x, which is 60, equals to the constant of proportionality, which is k. So 6 multiplied by 60, that will give us 360. So our k will be equal to 360. And now we will find for the second values of y and x. Okay, let's continue to read. What should be his average speed? So the average speed is the unknown. So that is x. So our x will be the unknown. And the value for y will be 5 hours. So this is y is equal to 5. Okay. So we are now going to solve for the value of x. Let us use the same equation, and that is yx is equal to k. Our value for y is 5, our x is the unknown, and k is 360. To solve for x, again, we need to cancel out 5. To cancel out 5, just divide both sides of the equation by 5. So we have here 5x times 1 over 5, that is 5x divided by 5, equals to 360 times 1 over 5, that's 360 divided by 5. So we have 5 divided by 5, 5 divided by 5, that is 1. And 1 multiplied by x, that is equal to x, and we have 360 divided by 5, that will give us 72. So 72 is the average speed, so its unit will be 72 kilometers per hour. So Clark must travel an average speed of 72 kilometers per hour to reach his destination within 5 hours. Okay, so let's change this so that it will be clear. Let's make that as 7. So 72 kilometers per hour. Problem number 5. 3 fishermen decided to contribute individually to purchase a boat worth $1,500. They decided to let other fishermen join them so they can lower their payments. How many fishermen will they need so that each one will pay $300? So first, we need to represent y. So we will represent y as the number of fishermen. And we will represent x as the amount of each amount to be paid by each fisherman. Okay, so we need to find the initial value of y and x, the initial values of y and x. So 3 fishermen, our y here will be 3. When x is equal to, they will purchase a boat worth $1,500. So X here, which is the amount to be paid by each fisherman, this will be 1,500 divided by the number of fishermen, which is 3. So X will be 500. Okay. And then we will find for K. So again, we will use the equation y multiplied by x equals to k. Our y is 3 multiplied by 500, and that will be equal to k. So our k is also 1,500. And the initial values of y and x. Our y will be how many fishermen. So our y here will be the unknown when x is equal to 300. So let us find the value of y. Again, we will use the equation yx is equal to k. Our y is the unknown, our x is 300, y equals to 1,500. Okay, so 300. Okay, so let's see. So 1,500. To find for y, we need to cancel out 300. So to cancel out 300, just divide both sides of the equation by 300. So we have here 300y times 1 over 300, that's 300y divided by 300. This will be equal to 1,500 times 1 over 300, that will be 15 divided by 300. So 300 divided by 300, that is equal to 1. And 1 multiplied by y is y. And 1,500 divided by 300, that is equal to 5. So the amount or the number of fishermen, this will be 5 fishermen. So the number of fishermen needed, so that each one will pay 300 for the amount of 1,500, is 5 fishermen. So they need 5 fishermen to contribute $300 each, so that the total will be 1,500. Direct variation, finding the values of x and y. Problem number 1. If y equals to 15 when x equals to 5, find y when x is equal to 4. The equation form of direct variation is y equals to the constant of proportionality multiplied by x. We are going to find 4k. Our y here is 15 and our x is 5. So we are going to find for the value of k. So to find for the value of k, this will be 15 equals to k multiplied by 5. To find for the value of k, we have to cancel out 5. To cancel out 5, divide both sides of the equation by 5. So 15 divided by 5 equals to k5 divided by 5. So 5 divided by 5, this will be equal to 1. And 15 divided by 5 is 3. So k is equal to 3. And then we need to find for y when x is equal to 4. So to find for y, we are going to use again y equals to k times x. Now the y is unknown. Okay, so y will be equal to, our k here is 3 and our x is 4. So y will be equal to 3 times 4, that is 12. So y equals to 12 and k equals to 3. They are our answers for number 1. Number 2, if y equals to 36 when x equals to 3, find y when x is equal to 6. Again, we are going to use y is equal to k multiplied by x. Our y here is 36 and our x is positive 3. We are going to find for k. So to find for k, we have 36 is equal to k times 3. And to find for k, we need to cancel out 3. So to cancel out 3, divide both sides of the equation by 3. So this will be 36 all over 3 and k3 all over 3. 3 divided by 3 divided by 3 is 1. And 36 divided by 3, that is 12. So k is equal to 12. And then we need to find y when x is equal to 6. Again, we will use y is equal to k times x. We need to find for y now. And our k here is 12. So we have here 12 multiplied by x, which is 6. So y will be equal to 72. So y equals to 72 is our answer for number 2. Number 3. If y equals to 14 when x equals to 2, find y when x is equal to 3. Again, we are going to use y is equal to kx. Our y here is 14 and our x is positive 2. We are going first to find for x. So to find for x, this is now 14 equals to k times 2. So to find for k, divide both sides of the equation by 2. So dividing, we have 14 divided by 2 is equal to k2 divided by 2. And we have here 2 divided by 2 is 1. 14 divided by 2 is 7. And this is equal to k. Now, we need to find for y when x is equal to 3. So y here will be equal to k times x. We are going to find for y. So y will be equal to, the value for k is 7. So this will be 7 multiplied by x, which is 3. So our y here will be 7 multiplied by 3, or 21. Y equals to 21 is our answer for number 3. Number 4. If y equals to negative 4, when x equals to negative 6, find x when y equals to 3. First, we need to find for k. So again, using the equation, y is equal to k multiplied by x. Our y is equal to negative 4 and our k is negative 6. So we need to find, or our x is negative 6. We need to find for k. So to find for k, we have negative 4 equals to k multiplied by negative 6. So we need to cancel out negative 6. So divide both sides of the equation by negative 6. So negative 4 all over negative 6. This will be equal to k times negative 6 divided by negative 6. So negative 6 divided by negative 6, that is positive 1. And negative 4 divided by negative 6, that is positive 2 over 3. And this is equal to 1 times k, of course, that is k. Now, we are going to find for x when y is equal to 3. Again, we are going to use y equals to k multiplied by x. But this time, we are going to find for x. So to find for x, we are going to transpose k to the other side, or we need to cancel out k here. So to cancel out k, we are going to divide both sides of the equation by k. So this will be y all over k equals to kx all over k. But k divided by k is equal to 1. So our equation for x is equal to y all over k. So x here, our value for y is 3. And our value for x is 2 over 3. So 3 divided by 2 over 3. So this will be 3 over 1 multiplied by the reciprocal of this, that is 3 over 2. So this will be 3 times 3, that is 9 all over 2. So 9 over 2 here is our answer for number 4. Number 5. If y equals to 3.6 when x is equal to 1.4, find x when y is equal to 0.18. Again, our equation is y is equal to k multiplied by x. Okay, so our y here, our y is, okay, let's erase that. So our y is equal to 3.6 and our x is 1.4. So we need to find for the value of k. So to solve for k, we have 3.6 is equal to k multiplied by 1.4. We need to cancel out 1.4. So to cancel out 1.4, divide both sides of the equation by 1.4. So 3.6 all over 1.4 and k times 1.4 all over 1.4. 1.4 divided by 1.4, that is positive 1. So we have 3.6 divided by 1.4. That will give us, okay, 2.57. And k multiplied by 1, that is equal to k. We now have the value for k. So we can now find for x when y is equal to 0.18. Again, we are going to use the equation y is equal to k times x. But again, we need to find for x. So using this equation, we have to cancel out k. To cancel out k, divide both sides of the equation by k. So y all over k is equal to k x all over k. And k divided by k, this is equal to 1. So y all over k is equal to 1 times x, that is x. Okay. So we can rewrite this. X will be equal to y all over k, and our value for y is 0.18, and this will be divided by the value of k, 2.57. So dividing, we have 0.18 divided by 2.57. That will give us 0.07. So 0.07 is our answer for the value of x for number 5. Combined variation examples and word problems. Here are some examples on how to write combined variation equations. So our first example, y is equal to. Now always remember that when writing combined variation equations, the right side is always a fraction. So there will be a numerator and a denominator. Okay, so on our first example, y is equal to, the first variable would always be the constant of variation, or k. So k will be multiplied by k times the variable x divided by the variable z. This is our first example. On to our next example. Y is equal to, again the first variable will be the constant of variation, and that is letter k. So k will be multiplied by x times z squared all over the variable w. Next example, y is equal to the constant of variation, and that is the letter k multiplied by x, or okay, let's change the color of that, multiplied by x and multiplied by z raised to the square of w. Okay, and the last example, y will be equal to the constant of variation, again that is represented by the letter k, and k will be multiplied by the square of x and divided by z times w. Okay, so these are some of the examples on how to write combined variation equations. And then we have here the variables w, x, y, and z. They are, or the letters, these letters, they are called variables. And then the letter k, this is the constant of variation. The constant of variation. Okay. Now, let us translate the English statements into mathematical equations. Okay. So, number 1, y varies jointly as x and inversely as z. Now, we will know that this is a combined variation because we have here varies jointly and inversely. So the first variable here, y. So since y is the one that varies jointly and inversely, this will be written on the left side. So y is equal to, so we have a fraction here, varies jointly. All variables that varies jointly, they will be written on the numerator. Okay, but do not forget that the first variable on the numerator will be the constant of variation, which is letter k. So k will be multiplied by the variables that varies jointly. So the variable that varies jointly here is only x. So this will be k multiplied by x. And the variables that vary inversely, all variables that vary inversely, will be written on the denominator. So we only have one variable here that varies inversely, and that is the letter z. so z will be on the denominator. Number 2 statement, y varies jointly as x and the square of y and inversely as w. So we have here again the variable y, which varies jointly and inversely. So since it is the variable that varies jointly and inversely, it will be written on the left side. So y is equal to, again we will have a fraction. And the first variable for our numerator is the constant of variation, that is the k. Now, the variables for the numerator, okay, y varies jointly as x, so x is a variable that varies jointly, and the square of y. So we have here two variables that varies jointly. We have the x and the square of y. So k will be multiplied by x and the square of y, or y squared. And the variable that varies inversely, okay, so our variable that varies inversely is w, and that is written on the denominator. Next example, y varies jointly as x and y and inversely as the square of w. Okay, again, the variable y is the one that varies jointly and inversely. So it will be written on the left side. Equals to, okay, so there will be a fraction here. And the first variable will always be the variable k, or the constant of variation. And this will be multiplied by all variables that varies jointly. So the variables that varies jointly, we have x and y. So this will be k multiplied by x and y. And the variables that varies inversely, we have the square of w. So this will be w raised to 2. And the last example, y varies jointly as the square of x and inversely as y and w. So again, we have the variable y that varies jointly and inversely. So it will be written on the left side. Equals to, so we will have a fraction here. Again, our first variable for the numerator will be the constant of variation, which is k. And this will be multiplied by the variables that varies jointly. So the variables that varies jointly, we only have one, and this is the square of x. So k will be multiplied by the square of x, or x squared. And then for our denominators, these are the variables that varies inversely. So the variable that varies inversely, we have two variables. We have y and w. So this will be kx squared all over w times y, or we can interchange that. So these are now our final answers in translating English statements to mathematical equations for combined variations. Addition and subtraction of radical expressions. In this video, I am going to show to you how to add and subtract different radical expressions. So stay tuned from start to finish, because we will be discussing basic to complex problems. Okay, so for example, our problem here will be 9 square root of 2 plus 3 square root of 2. In this problem, we can add directly the radicals, because the radicand, or the number or expressions inside the radical symbol, they are the same. So once the radicands are the same, we can add them directly. So to add this, we will just combine the numbers outside the radical symbols. So we will just combine 9 plus 3, and then we will copy the radical sign together with the radicand, which is 2. So our final answer here will be 9 plus 3, that is 12 square root of 2. Okay. Okay, our next problem, we will have 18 square root of 5 plus 7 square root of 5 minus 9 square root of 5. In this problem, we can see that we have the same radicands, or the numbers or expressions inside the radical symbol. So our radicand here is positive 5. So since they are the same in the three expressions, we can add directly the numbers outside the radical symbol. So what are the numbers outside the radical symbols? We have positive 18 plus 7 minus 9. So combining, we will have 18 plus 7 minus 9. And then we will just copy the radical symbol, that is the square root, and the radicand, which is 5. Okay. So we will have 18 plus 7, that is 25, minus 9, that is positive 16, and just copy square root of 5. So positive 16 square root of 5 is our final answer. Okay, our next problem, we will have 40 and the fourth root of a minus 30 and the square root of b plus 18 and the fourth root of a plus 15 and the square root of b. Now remember that we can only add radicals with the same radicands. Okay, so we can add 40 and the fourth root of a, as well as plus 18 and the fourth root of a. Okay, so we can add this 40 and the fourth root of a plus 18 and the fourth root of a. And we can also add separately negative minus 30 square root of b and positive 15 square root of b. Okay, so combining, we will have here negative 30 square root of b and positive 15 square root of b. So adding, we will have 40 plus 18, that will be 58. 58 fourth root of a. And then we have negative 30 plus 15, that will be negative 15. And then copy the radical, which is square root of b. So therefore, 58 fourth root of a minus 15 square root of b, this is now our final answer. Our next problem, we will have positive 16 square root of xy plus positive 10 square root of ab minus 20 square root of xy minus 9 square root of ab. Okay. So looking at the problem, we can see that we have two types of radicands, or we have two radicands. First is the radicand xy. So we have two here. We have 16 square root of xy and minus 20 square root of xy. So we can combine this directly. Okay, so we can have 16 square root of xy minus 20 square root of xy. And then our next radicand is the square root, or the next radical is the square root of ab. So we have here positive 10 square root of ab and minus 9 square root of ab. So combining, we will have positive 10 square root of ab minus 9 square root of AB. So we will have 16 minus 20. This will give us negative 4. And then just copy the radical and the radicand, square root of xy. And then positive 10 minus 9, we will have plus 1, and copy the radical, which is square root of AB, or we can rewrite this as negative 4 square root of xy plus 1 multiplied by square root of AB. This will give us square root of AB. So negative 4 square root of xy and plus square root of AB is our final answer. Our next problem, we will have 5 square root of L minus 14 square root of M plus 6 square root of N minus 15 square root of L plus 3 square root of M minus 26 square root of N. Okay, so again, remember that we can only combine radicals with the same radicands. Okay, so we have here 3 radicands. So we have L, so 5 square root of L. This is one expression, and we can combine that with negative 15 square root of L. So they have the same radicand, which is L. So our next radicand is M. So we can combine negative 14 square root of M and positive 3 square root of M. Our third radicand is N. So we can combine positive 6 square root of N and negative 26 square root of N. So combining, we will have 5 square root of L minus 15 square root of L, and then minus 14 square root of M plus 3 square root of M, and then we have plus 6 square root of N minus 26 square root of N. So subtracting and adding, we have 5 minus 15, that is negative 10 square root of L, and then negative 14 plus 3, that is negative 11 square root of M, and positive 6 minus 26, that will be negative 20 square root of N. So we cannot combine this anymore. Negative 10 square root of L, negative 11 square root of M, and negative 20 square root of N, they are our final answers. Our next problem, we have square root of 5 over 3 minus the square root of 135. Now, to subtract these radicals, we will first simplify the square root of 5 over 3. Since this is a fractional radicand, okay, so this is what we are going to do. So square root 5 over 3. To simplify this, we are going to multiply this by a fraction. So the numerator and the denominator will be the same as our denominator. So we are going to multiply this by 3 over 3. Okay, so minus the square root of 135. So we will have here the square root of 5 times 3, that is 15, and 3 multiplied by 3, that is positive 9, minus square root of 135. Okay, so we are not going to touch this first. Now, looking at this fractional radicand, we can rewrite this as the square root of 15 Okay, so we will separate the square root of the numerator all over the square root of the denominator. So square root of 15 divided by the square root of 9 minus. Now, we can now, okay, touch square root of 135. So let us find a number, or let us find the factors of 135, wherein one of the factors will be equal to 15. Okay, so we will divide 135. Let's divide that by 15. Okay, there. So we can have 15 times 9. Okay, so we have the square root of 15 here, and the other factor is 9. Okay, now let's continue. We cannot simplify square root of 15, so this will be square root of 15. But we can simplify square root of 9, and the square root of 9 is 3. So minus. Okay, we cannot simplify square root of 15, but we can simplify the square root of 9. The square root of 9 is 3. And what will be left here will be the square root of 15. Okay, so since square root of 15 is present, okay, since square root of 15 is present on the two expressions, okay, we can simplify this, or we can factor this out. So what we will have here, we will have two expressions, and this will be multiplied by square root of 15. So square root of 15 all over 3 divided by the square root of 15. So what will be left here will be 1 all over 3. So square root of 15 times 1 over 3 is also equal to the square root of 15 all over 3 minus. So 3 square root of 15 divided by square root of 15, what will be left here is 3. So again, square root of 15 multiplied by 3 is equal to 3 times the square root of 15. Okay, so we can simplify 1 over 3 minus 3. This will give us minus 2 and 2/3 square root of 15. Okay, so let us make this as an improper fraction. So this will be negative. 2 times 3 is 6, plus 2, that is 8. So this will be negative 8 over 3 times the square root of 15. So negative 8 over 3 multiplied by the square root of 15 is our final answer. Our next problem, we have the square root of 2 over 3 plus the square root of 54. Okay. So to do this, we will first simplify the radicand with the fractional exponent. Okay, so to simplify this, we have square root of 2 over 3. We will multiply this by a fraction. So the numerator would be the same as the denominator here, so that is 3. And the denominator would also be the same as the denominator, so that would also be 3, plus the square root of 54. So we will not touch square root of 54 first. Okay, so continuing, we will have 2 multiplied by 3, that is positive 6, all over 3 times 3, that's positive 9, plus square root of 54. Now, we can rewrite this, okay? So we can rewrite this as the separate radicals, okay? So we can rewrite the numerator as the square root of 6, and the denominator will be the square root of 9, okay? Plus, okay, so we will now touch the square root of 54. The square root of 54, we will find one factor which is equal to 6, okay? So we will have 54 divided by 6. So that will be 9 times 6. So this will be 9 multiplied by 6. And then continuing, we will have the square root of 6 all over the square root of 9. Now the square root of 9 is 3 plus the square root of 9 here, that is also equal to 3. So we can factor that out. And what will be left here will be the square root of 6. And then looking at the two expressions, we can see that the square root of 6 is common between the two terms. So we can factor this out. So factoring, we will separate this. So we will take out square root of 6. So what will be left on the first term will be 1 all over 3. Okay, when you multiply that with 1 over 3 times 1 times the square root of 6, this will be equal to the square root of 6 plus 3. And the second term, what will be left here will only be 3. So when you multiply that, that will be 3 times square root of 6. Okay, so we can now add the 2. So this will give us 3 and 1 over 3 square root of 6. Or this will be 3 times 3, that is 9, plus 1, 10. 10 over 3 square root of 6. So therefore, 10 over 3 times the square root of 6 is our final answer. Next problem, we will have the square root of 1 over 2 plus the square root of 32 minus the square root of 8. Okay, so first we are going to simplify the radicand with the fractional part. Okay, so we will first simplify square root of 1/2. So this will be 1/2, and then we will multiply this by a fraction. The numerator and the denominator would be the same as our denominator. So we are going to multiply 1/2 by 2 over 2 plus square root of 32 minus square root of 8. So later we will touch square root of 32 and square root of 8. Okay, so we will have here this square root 1 times 2, that will be positive 2, all over 2 times 2, that is positive 4, plus the square root of 32 minus the square root of 8. Okay, so we can rewrite square root of 2 over 4 by the square root of 2 all over the square root of 4. Okay, and then we will now touch positive square root of 32 and negative square root of 8. Okay, so plus square root of 32. So we will factor out 32 with two factors wherein one is positive 2. So all we have to do is divide 32 by 2. So 32 divided by 2, this will give us 16. So this will be 16 times 2 minus, again factor out 8 by 2. So 8 divided by 2, this will give us 4 times 2. Okay, so square root of 2, we cannot factor this out, so this will be square root of 2. Square root of 4 is 2 plus square root of 16, that is 4, and 4 multiplied by 2 minus square root of 4 is 2 times square root of 2. Okay, looking at the three expressions, we can see that square root of 2 is common among the three terms, so we can move out square root of 2 from the three terms. So factoring, we will have here, okay, so we will move out square root of 2 from the three terms. So square root of 2 divided by 2 and divided by the square root of 2, what will be left here will be 1/2 plus 4 square root of 2 divided by square root of 2. So what will be left will only be 4 minus 2 square root of 2 divided by square root of 2. What will be left here will be minus 2. So to check, 1/2 times square root of 2, that will be square root of 2 divided by 2. Positive 4 times square root of 2, that will be 4 times square root of 2. Okay. And then we will have negative 2 times square root of 2. So we will have here negative 2 times square root of 2, that will be negative 2 square root of 2. So combining, we will have 1/2 plus 4, that will give us 3, and okay, let's add here. So we will have 1/2 plus 4 minus 2. This will give us 2 and 1/2 square root of 2. Or we will have here 2 times 2, that is 4, plus 1. This will be 5 over 2 times square root of 2. So 5 over 2 square root of 2 is our final answer. Next problem, we will have the square root of 48 plus the square root of 3 over 4. So to solve this, we will not touch square root of 48 first. We will start to simplify square root of 3 over 4. So we have here 3 over 4. Multiply this by a fraction wherein the numerator and the denominator would be the same as the denominator here. So this will be multiplied by 4 over 4. So we have square root of 48 plus the square root of 3 times 4, that is 12 all over 16. Okay. So this will be square root of 48 plus the square root. We can rewrite this as the square root of 12 divided by the square root of 16. Okay. So we will now factor out 48, wherein one of the factors is 12. Okay. So 48 divided by 12, this will give us positive 4. So this will now be the square root of 4 times 12 plus the square root of 12. We cannot simplify this. All over square root of 16, that is 4. So square root of 4 is 2 times the square root of 12 plus the square root of 12 all over 4. Now, since square root of 12 is common between the two terms, we have here square root of 12 and we also have here square root of 12, we can factor that out. So factoring, we will have, okay, so square root of 2, or rather square root of 12, will be on the outside. So what will be left here will only be 2 plus what will be left here will be 1 over 4. So to check, we have 2 times square root of 12, that will be 2 square root of 12, and 1/4 times square root of 12, that will be square root of 12 all over 4. So we will have here 2 plus 1/4, that is 2, and 1/4 square root of 12, or 4 times 2 is 8, plus 1, that is 9 over 4 square root of 12. So therefore 9 over 4 square root of 12 is our final answer. Our next problem, we will have the square root of 200 minus the square root of 1 over 8. So to solve this, we have square root of 200 minus square root of 1 over 8. We will multiply this by a fraction wherein the numerator and the denominator would be the same as our denominator here. So we are going to multiply this by 8 over 8. So we have the square root of 200 minus the square root of 1 times 8, that is 8, all over 8 times 8, that is 64. So we will have here the square root of 200 minus, we can rewrite this, we can rewrite it as square root of 8 all over the square root of 64. Okay, so we can factor out 200 wherein one of the factor is 8. So 200 divided by 8, that will give us 25 times 8. So this will be the square root of, so this will be the square root of 25 times 8 minus square root of 8. We cannot simplify that, so this will be square root of 8 all over square root of 64, that is positive 8. And then square root of 25, that is 5. So what will be left will be the square root of 8 minus the square root of 8 all over 8. So we can see on the two terms that square root of 8 is common among them. So we have here square root of 8, and we also have here square root of 8. We can factor this out. So to factor out, we will move out square root of 8. So what will be left here will only be 5 minus, okay, what will be left here will only be 1 over 8. So to check, we have 5 times square root of 8, that will be 5 square root of 8 minus 1 over 8 times square root of 8, that will be square root of 8 divided by 8. Okay, so we have 5 minus 1 over 8. This will give us 4 and 7 over 8 square root of 8, or this will give us 8 times 4, that will be 32, and 32 plus 7, that will be 39. So this will be 39 all over 8 times square root of 8. So 39 over 8 times square root of 8 is our final answer. Our first problem, okay, simplifying radicals. We will have the fourth root of 405 multiplied by x raised to 6 and y raised to 7. Okay, so looking at the problem, first we need to think of the factors of 405. So what will be the factors of 405? Okay, so you think of two numbers wherein one number will have the fourth root. Okay, so the two numbers here, or the two factors of 45, this will be 81. Okay, so 81 and 405 divided by 81, this will give us, okay, that's correct, this will give us positive 5. So the factors of 405 that we will use will be 81 and 5. Okay, let's continue. We will then have here, we can factor out x raised to 6. So one of the factors will be, of course, x raised to 4. So x raised to 4. And then this will be multiplied, of course, by the remaining. This will be x raised to 2. And then let's factor out y raised to 7. So the first will be, of course, y raised to 4. And the remaining will be y raised to 3. Okay. So we will then separate those that are the fourth root. Okay. So the terms with the fourth root. So the terms with the fourth root will be 81 and x raised to 4, and then y raised to the fourth. Okay, so we will just rewrite this longer statement. So we will multiply this, okay, by the fourth root also. So take note, we are going to multiply that by the fourth root also. So what are we going to put inside these radical symbols? those that are left behind. So we have 5, and then we have x squared and y raised to the third. Okay, so we can now simplify. The fourth root of 81 is 3. The fourth root of x raised to 4 is x. The fourth root of y raised to 4 is y. And then multiply this, okay, by the fourth root. Now we cannot simplify this anymore, so we will just copy 5x squared y cubed. So therefore, 3xy times the fourth root of 5x squared y cubed is our final answer. Our next problem, we will have the square root of 448 multiplied by y raised to 9, z raised to 5, and x raised to 8. So to simplify this, let us first concentrate on 448. So we will think of two numbers which are the factors of 448, and one of the factor will be the square root, or will be a perfect square. So the two numbers that were in one as a perfect square will be 64 multiplied by, so 448 divided by 64, this will give us 7. So 64 and 7 are the factors of 448, and 64 is a perfect square. Okay, and then we are going to factor out y raised to 9. So one of the factors will have a maximum even exponent. So the maximum even exponent here will be y raised to 8. Y raised to 8, so the square root of y raised to 8, we can get that later on. So what will be left here will be multiplied by y. Okay, so let's proceed now to z raised to 5. Okay, so again, one of the factor will have a maximum even exponent, so that will be z raised to 4, and what will be left will be z. And then let's continue, x raised to 8. Now, x raised to 8, the exponent is already an even, maximum even exponent. We will just copy this. So our next step, we are going to separate those that are not perfect square. Okay, so 64 is a perfect square, y raised to 8, z raised to 4, and x raised to 8. Those that are not perfect square, we have 7, y, and z. Okay, so continuing, we will have the square root of 64 multiplied by y raised to 8 multiplied by z raised to 4 multiplied by x raised to 8. Okay, and we are going to multiply this by those that will be left behind, but do not forget to enclose them on the square root sign. So those that will be left behind will be 7, y, and z. Okay, so we can now simplify. The square root of 64 is 8. The square root of y raised to 8 will be y raised to 4. The square root of z raised to 4 is z raised to 2. And the square root of x raised to 8 will be x raised to 4. And we cannot simplify square root of 7yz, so we will just copy this. The square root of 7yz. We can rewrite this in alphabetical order, so we will have 8x raised to 4, y raised to 4, z raised to 2, and the square root of 7yz. So this is now our final answer. Next problem, we will have the 6th root, okay, the 6th root of 4. Okay, so though it's difficult to solve this, we can simplify this by factoring out the 6th root. Okay, so as one of the rule, we can factor out the roots of a radical. Now, how do we factor out the 6th root? Okay, so the factors of 6 that we will be using will be the cube root. So this will be 3 here, and then the remaining root will be put inside. Okay, so 6 divided by 3, that will be 2. So this will be the square root. The square root of our given is 4. Okay, so continuing, we can now simplify. So this will be the cube root, and then the square root of 4 is 2. So that's the final answer, the cube root of 2. Okay, another example. Let's say the 8th root of 9. Okay, the 8th root of 9. So we will think of another root wherein we can get the perfect root or a perfect value for 9. So the best or the root here that will give us will be the square root. So we will factor out 8 and 2. Okay, so the factors of 8, wherein one of the factors is 2, will be, we will have here 4. Okay, so this will be the 4th root, and the other root will be the square root. So this will be the square root of 9. And then the final answer now, or the simplified answer, will be the 4th root. The square root of 9 is 3. So the 4th root of 3 is our final answer. Okay, and then we will have the 4th root. The 4th root of 81. So the 4th root, okay, rather the 4th root of the square root of 81. Now, in one of the rules, we can interchange the roots. So the 4th root, we can interchange that. It will be inside, and the square root will be on the outside. Okay, so interchanging the roots, we will have here the square root. This is now on the outside, and what will be on the inside now will be the 4th root. So this will be now the 4th root of 81. Okay, and then computing, we will have the 4th root of 81 is 3. So what will be left here will be the square root, and the 4th root of 81 is, okay, the 4th root of 81, that is equal to 3. So the square root of 3 is now our final answer. Our next problem, we will have the cube root of 3 all over 4k. So we will be simplifying a radical with a fractional radicand. Okay, to simplify this, so first we are going to rewrite this. So we will have a numerator and the denominator. So the numerator here will be the cube root, okay, the cube root of the numerator, and the denominator will be the cube root of our denominator, which is 4k. Okay, so we are then going to solve this or simplify this. So to simplify this, first we will just copy here. Okay, so we will leave it as is as of this time. So this will be cube root of 3, and then for the denominator, so we will have here the cube root, but we know that 2, rather that 4 is equal to 2 raised to 2, and that k is equal to k raised to 1. And then our next step, we will multiply this by a numerator and the denominator. The numerator will be the same as the denominator. So what are we going to multiply? So we first, we will copy the root. So the root is cube root, so we will copy that. And then since we have here 2 raised to 2, okay, so our exponent here is 2, and then 3 minus 2 is 1. So we will just make the exponent equal to 3. So all we need to do here will be 2, and 3 minus 2 is 1, so this will be 2 raised to 1. And then for the exponent of k, our exponent here is 1. So 3 minus 1 is 2. So the exponent for k that we need will be 2. So this will be 2 raised to 1 multiplied by k raised to 2. Okay, so for the numerator, we will just copy our denominator, which is the cube root of 2 raised to 1 times k raised to 2. Okay, and then we can continue. So we will have here the cube root of 3 multiplied by the cube root, okay, of 2 raised to 1, that is 2, times k raised to 2. So we will now have here the cube root of 2 raised to 2 multiplied by 2 raised to 1 multiplied by k raised to 1 times k raised to 2. Okay, so we can continue. So we will just copy the cube root. So we have here the cube root 3 times 2 times k raised to 2. Okay, all over the cube root. Okay, so we have here the cube root. Okay, copy the base, which is 2, and then add the exponent. So 2 plus 1, that is 3, multiplied by, again, copy the base, k, add the exponents, 1 plus 2, that is 3. So we will have here, so we have the cube root of 3 times 2, that is 6, and k raised to 2. So we cannot simplify this anymore, so that will be our numerator. But we can simplify this. The cube root of 2 raised to 3 is 2, and the cube root of k raised to 3 is k. So therefore, the cube root of 6k squared all over 2k is our final answer. Our next problem, we will have here the fifth root. So the fifth root of 7 all over 27 x squared, okay, and y cubed. So to simplify this, we are going first to rewrite the given. So we can rewrite this as the fifth root of 7, and the denominator would still be the fifth root. Okay, so the fifth root of our existing denominator, which is 27 x squared y cubed. Okay, so we will then multiply this by a fraction, so a numerator and the denominator, but the numerator would be the same as the denominator. So what are we going to put here? Okay, so first, let us simplify the denominator here. We can still simplify this. So simplifying, we will have here, okay, let's copy this first, okay, so the fifth root of 7, and this will be the fifth root. Now, we need to simplify 27. So 27 here, let's change this into an exponent. So to change this into an exponent, this will be 3 raised to the power of 3. Okay, so we have 3 raised to the power of 3. And then our next will be x raised to 2, and then y raised to 3. Okay, So this is now where we will multiply them by a numerator and a denominator. Okay, so our denominator here, this will be the fifth root. Okay, so we are going to make this exponents, the total exponents, equal to 5. So we are going to make them equal to 5. Okay, so this will now be this fifth root. For 3 here, the exponent of 3 will be 5 minus 3, so we need to put here 2. And the exponent of x, that will be 5 minus 2, that is 3. And for the exponent of y, we have 5 minus 3, that is equal to 2. For the numerator, we will just copy the denominator, that is the fifth root of 3 raised to 2, x raised to 3, and y raised to 2. So continuing, we will have the fifth root of 7. Okay, multiply this by the fifth root of 3 raised to 2, that will be equal to 9. Okay, so this will be 3 raised to 2. Okay, 3 raised to 2. So this will be 9. And then x cubed y squared all over. Okay, we can combine this. We can now combine the denominators. This will be the fifth root of, so 3 raised to 3 times 3 raised to 2. So 3 raised to 3 multiplied by 3 raised to 2 times x raised to 2 times x raised to 3 times y raised to 3 times y raised to 2. So this will be, okay, so we will have here the fifth root. Okay, so 7 multiplied by 9, that will give us 63. And then we will just copy x cubed y squared all over. So this will be the fifth root of 3, and then 3 plus 2, that is 5, times x. 2 plus 3 is 5, times y. 3 plus 2 is 5. Okay, so continuing, we will have here the fifth root of 63 x cubed y squared all over. Okay, 3 raised to 5, the fifth root of 3 raised to 5, that will be equal to 3. And the fifth root of x raised to 5, that is equal to x. And the fifth root of y raised to 5, that is equal to y. So therefore, 5 times the square root, or rather the fifth root of 63 x cubed y squared all over 3xy is our final answer. Our next problem. So our given will be the fourth root of 1 all over 72. So let us first rewrite this. So we will have here the fourth root of 1 all over the fourth root of 72. And then we are going to factor out 72. So this will be the fourth root of 1 all over. So let's think of the factors of 72 wherein one of the factors will be a whole number. Okay. So the maximum factor of, okay, let's write that first. 72 will be 36 times 2. Okay. But we can still convert 36 into an exponential form. So converting, we will have here the fourth root of 1 all over the fourth root. Okay, now convert 36 into an exponential form. So this will give us 6 raised to 2. Multiply this, 2 raised to 1. So take note that our exponents are 2 and 1. So we will multiply this by the exponents of the same bases, and the sum should be equal to 4. Okay, so let's multiply this by a numerator and the denominator. So the numerator and the denominator would be the same. So what are we going to write here on the denominator? So this will be the fourth root. Now 4 minus 2, that is equal to 2. So the exponent of 6 here will be equal to 2. And then 4 minus 1 is 3. So the exponent of 2 will be 3. Okay, so we will just copy the denominator. So this will be 4th root of 6 raised to 2 times 2 raised to 3. Okay. So we will have here the 4th root of 1 times the 4th root of 6 raised to 2, that will give us 36, multiplied by 2 raised to 3, that will give us 8, all over the 4th root. Okay, so the 4th root of 6 raised to 2 times 6 raised to 2 times 2 raised to 1 times 2 raised to 3. So this will be the 4th root of 1 times 36 times 8, all over. So this will now give us the 4th root of, copy the base, 6, and then add the exponent. So 2 plus 2, that is 4. Times, copy the base and add the exponents, 1 plus 3 is 4. So this will give us 1 times 36 times 8. So that will give us the 4th root of 288, all over. Okay, the 4th root of 6 raised to 4 is 6. And the 4th root of 2 raised to 4 is 2. So this will be 6 times 2. Okay, now we can still factor out 288. Okay, so the factors of 288 will be the 4th root of 16 times 18, all over 6 times 2, that is 12. And we can still rewrite this. So this will be the 4th root of 16 multiplied by the 4th root of 18, all over 12. The 4th root of 16, that is equal to 2. And we cannot simplify this anymore, so this will be that will be the 4th root of 18. So 2 times the 4th root of 18, all over 12. But we can simplify this. So 2 all over 12, so this will give us 6. So therefore, the 4th root of 18 all over 6, this is now our final answer. Problem number 7, or rather next problem. Our next problem will be the 5th root of 1 all over 192. So we can rewrite this. So we will have the radical symbol on both the numerator and the denominator. So this will be the 5th root of 1, and this will be the 5th root of 192. And then let us factor out 192, wherein one of the factor is a prime number. Okay, let's try if we can factor that out. So this will be the 5th root. Okay, so the factors will be 64. So 192 divided by 64, that is equal to 3. So the factors will be 64 and 3. And then we will still have here the 5th root of 1. Now, let's change this into exponential forms. Okay, so still copy this, 5th root of 1. For our denominator, we are going to convert them into exponential forms. So 64, this will be equal to 4 raised to 3 multiplied by 3 raised to 1. Okay, so we are going to multiply this by a fraction. The numerator would be the same as the denominator. So our denominator here, so that will still be the fifth root. And then we will base our exponents on the given exponents here. So we have here 3 and we have here 1. Okay. So the first exponent, or the exponent of 4, will be 5 minus 3, that is equal to 2. So this will be 4 raised to 2 multiplied by 5 minus 1, that is equal to 4. So this will be 3 raised to 4. And then we will just copy the denominator. So this will be the fifth root of 4 raised to 2 multiplied by 3 raised to 4. Okay. So continuing, we will have the fifth root of 1 and multiply this. Okay, we can now combine this. 4 raised to 2 by 3 raised to 4. Okay, all over. So we will have here the fifth root of 4 raised to 3 multiplied by 4 raised to 2 multiplied by 3 raised to 1 times 3 raised to 4. So this will be the fifth root of 1, okay, times 4 raised to 2 is 16 times 3 raised to 4, that will be 81 all over. Okay, so this will be the fifth root 4 raised to 5 times 3 raised to 5. Okay, now the fifth root of 1 times 16 times 81, this will give us 1296 all over. Now the fifth root of 4 over 5, that will be equal to 4, and the fifth root of 3 raised to 5, that is equal to 3. Okay, now looking at the numerator, we cannot simplify this anymore. Okay, so this is the fifth root. So therefore, this is still the fifth root of 1296 all over 4 times 3, that is 12. So therefore, the fifth root of 1296 divided by 12 is our final answer. Our next problem will be the sixth root of 1 all over 2s. Okay, so again, let us rewrite this. So this will be 6 root of 1 all over the 6th root of 2s. And then let us make it into exponential form, our denominator. So this will be 6 root of 1 all over the 6th root of 2. So this will be 2 raised to 1 multiplied by s. Again, this will be s raised to 1. And then we are going to multiply this by a fraction. So the numerator would be the same as the denominator. Okay, so let us just copy the radical or radical sign, that is the 6th root. And then for the exponents, that will be, so our exponents here, we have 1 and 1. So our first exponent, or our exponent for 2, will be 6 minus 1, that is 5. So this will be 2 raised to 5 multiplied by the exponent of s, that will be 6 minus 1, that is also equal to 5. So we will just copy our denominator. So this will be the 6th root of 2 raised to 5 times s raised to 5. Okay, so continuing, we will have, so we can combine. So this will be the 6th root of 1 times 2 raised to 5 times s raised to 5 all over, okay, the 6th root of 2 raised to 1 times 2 raised to 5 times s raised to 1 times s raised to 5. Okay, so this will now be the 6th root. Okay, so 2 raised to 5, we will have here 1. 2 raised to 5 is 32 times s raised to 5 all over the 6th root of 2 raised to 6 multiplied by s raised to 6. Okay, so simplifying, this will be the 6th root. So 1 times 32, that will be 32 s raised to 5 all over the 6th root of 2 raised to 6 is 2, and the 6th root of s raised to 6 is 6. So therefore, the 6th root of 32 times s raised to 5 all over 2s is our final answer. Solving quadratic equations by extracting square roots. Our first problem, we have b squared minus 64 equals to 0. So this is a quadratic equation because of the exponent 2, and we can extract the square root because 64 is a perfect square. So to find for the value of b, we first need to separate b squared and 64. So to separate them, we need to transpose negative 64 to the other side. So transposing, what will be left on the left side will be b squared. And if we transpose negative to the other side, this will change its sign. This will become positive 64. And then to find for the value of b, we need to extract the square roots. Okay, so we need to raise both sides of the equation to 1/2. So b squared raised to 1/2, 64 raised to 1/2. Okay. So the exponent here, the denominator of the exponents, this will be the equivalent of the roots. So since 2 is their root, this will be the square. So this will be the square root. Okay, our base is b squared, and the exponent here will be the numerator. So our numerator of the our numerator here is 1, so that will be the exponent of b squared. So this will be b squared raised to 1. This is equal to, again, that is the square root, since this is 2, and our base is 64. And then this will be raised to the exponent of 1, since 1 is our numerator. So this will be 64 raised to 1. Now, this is now equal to b squared, and this is the square root of 64. Now, the square root of b squared is b, and the square root of 64, there will be 2 roots, so we will have plus minus. The square root of 64 is plus minus 8. Okay, let us check if our answers are correct. So check. So for b equals to positive 8, and for b equals to negative 8. So we have here b squared minus 64 equals to 0, and also b squared minus 64 equals to 0. So our b here is positive 8 raised to 2 minus 64 equals to 0. And our b here, that is negative 8 raised to 2 minus 64 equals to 0. So positive 8 raised to 2 is 64 minus 64 equals to 0. And negative 8 raised to 2, that is also 64 minus 64 equals to 0. So 64 minus 64 is 0. So 0 is equal to 0. So our first value is correct. Okay. Our next value, 64 minus 64, this is also equal to 0, equal to 0. So our second value, which is b equals to negative 8, is also correct. So these are our final answers. Solving quadratic equations by extracting square roots. Our next problem is a squared equals to 256. So to extract the square root, so we will have here a squared. We are going to raise both sides of the equation by 1/2. So we are going to raise this by 1/2, raised to 1 over 2, 256 raised to 1 over 2. So if we are going to raise this, the denominator here, this will be our root, and the numerator will be the exponent of the base. Okay, so this will be equal to the square root. Our base here will be a squared, and our numerator of the exponent, so this will be the exponent of the base, that is equal to 1. And this is also equal to the square root. Our base will be 256. Our exponent will be the numerator, and that is 1. So this will be a squared, the square root of a squared, equals to the square root of 256. The square root of a squared is equal to a, and we have here the square root of 256. There will be two roots, the positive and the negative. So this will be positive and negative, and the square root of 256 is 16. And now let us check if our answers are correct. So we are going to substitute a equals to positive 16, and also another a, which is negative 16. Our equation is a squared equals to 256. Another a squared equals to 256. So our a here is positive 16 raised to the power of 2. And this is 256. So we have here negative 16 raised to the power of 2 equals to 256. So 16 raised to 2 is 256, and this is equal to 256. Negative 16 raised to the power of 2, this will be positive 256 equals to positive 256. So therefore, our two answers are correct. Solving quadratic equations by extracting square roots. Our next problem, we have 49. B squared is equal to positive 17689, or positive 17,689. So to solve for this, first we need to cancel out 49 from 49b squared. So to do this, we need to divide both sides of the equation by 49. So dividing, we will have 49b squared all over 49. This will be equal to 17,689 divided by 49. So 49 divided by 49, okay, we can cancel this out, that is equal to 1. So what will be left on the left side will be b squared. And then we have 17,689 divided by 49. That will give us 361. To find for b, we need to extract the square root of both sides of the equation. So to extract the square root, first we need to raise both sides of the equation by 1/2. Raise this to 1/2. Okay. Now, since the denominator of the exponent is 2, this will be the square root. Okay, so the square root on the left, and the same is true on the right side, also the square root. So our base here is b squared. The exponent here will be the numerator, and the numerator is 1, so that will be b squared raised to 1. Our base here is 361. The exponent is also 1, so 361 raised to 1. This will be the square root of b squared equals to the square root of 361. Now, the square root of b squared, this will be positive b, and we have here the square root of 361. We will have two values, the positive and the negative. So 361, the square root of 361 is 19. Now let us check if the answers are correct. So first, b is positive 19. And we also have b, which is negative 19. So our equation will be 49. Our b here is positive 19 squared equals to 17,689. So for here, we also have 49 times negative 19 raised to 2 equals to 17,689. So we have here 49 and we have 19 squared. This will be 361 equals to 17,689. So this will be 49 negative 19 raised to 2, that will be 361, and this is 17,689. 49 multiplied by 361, this is 17,689. So 14,689. Again, this is 17,689, also equal to 17,689. So therefore, our answers for B, which are positive 19 and negative 19, are correct. Solving quadratic equations by extracting square roots. Our next problem, we have 16x squared minus 64 equals to 0. To solve for the value of x, first we need to separate negative 64 to the other side. So to do this, we need to transpose negative 64 to the other side. So transposing, what will be left on the left side will only be positive 16x squared. So if we transpose negative, this will change sign. From negative, this will become positive 64. And next, we have to cancel out 16 from 16x squared. So to do this, we need to divide both sides of the equation by 16. So 16x squared divided by 16 and 64 divided by 16. So dividing 16 divided by 16, we can cancel this out since this will be equal to positive 1. So 1 multiplied by x squared, this will give us x squared. And then we have 64 divided by 16, this will be equal to 4. And to solve for x, we need to extract the square roots. So extracting, we are going to raise both sides of the equation by 1/2. So since the denominator of our exponent, they have 2 as denominator, this will be equivalent to the square root. So this will also be the square root. And then our base here is x squared. and its exponent will be the numerator. So its exponent will be 1. And our base here is 4. Its exponent will be 1. The square root of x squared, that will give us positive x. And the square root of positive 4, there will be two values, positive and negative, and this will be 2. Let us now check if our answers are correct. So our first value of x is positive 2. The second value of x is negative 2. Our equation is 16 x squared minus 64 equals to 0. We have here also 16 x squared minus 64 equals to 0. So our value for x is positive 2. This will be squared minus 64 equals to 0. So we will also have here 16. Our value of x here is negative 2 raised to the power of 2 minus 64 equals to 0. So we will have here 16, 2 raised to the power of 2, that is positive 4, minus 64, this will be 0. And 16 multiplied by negative 2 raised to the power of 2, that will be positive 4, minus 64, and this will be equal to 0. So 16 times 4, that is 64, minus 64, this is equal to 0. So 16 times 4, still 64, minus 64 equals to 0. So 0 equals 0, 0 equals to 0. So therefore, our values for x, which are positive 2 and negative 2, they are correct. Solving quadratic equation by extracting square roots. Our next problem, we have positive 49 d squared minus 12,544 equals to 0. So to solve for the value of d, first we need to transpose negative 12,544. So we need to transpose this to the other side. So transposing, what will be left on the left side will only be 49 d squared. And if we transpose negative to the other side, this will become positive 12,544. And to find for the value of d, we need to cancel out 49 from 49d squared. So to cancel out, we are going to divide both sides of the equation by 49. So 12,544 divided by 49. So 49 divided by 49, we can cancel this out since this is equal to 1. And 1 multiplied by d squared, this is positive d squared. And we have here 12,544 divided by 49. This will give us positive 256. To find for the value of d, we need to extract these square roots. So to extract the square roots, let us raise both sides of the equation to 1 over 2. So raise both sides of the equation by 1 over 2. Now, since both of the denominators of the exponents is 2, this is equivalent to the square root. So we have here the square root on the left and the square root on the right. And the base here will be d squared. The exponent will be the numerator. So the numerator is 1. And we have here 256. The exponent is also 1. So this will be the square root of d squared, and the square root of d squared is d. And then the square root of 256, we will have two values that will be positive and negative. And that will be plus minus 16. Let us now check if our answers for D are correct. Our our equation is 49D squared minus 12,544 equals to 0. So we have here 49D squared. Okay, let us erase that. Let us rewrite so that it will fit. Okay. So this will be 49D squared minus 12,544 equals to 0. And 49D squared minus 12,544 equals to 0. So our D here, 49 multiplied by 16, positive 16, raised to 2 minus 12,544 equals to 0. So 49 multiplied by negative 16 raised to 2 minus 12,544 equals to 0. So we have here 16 raised to the power of 2, that will give us 256. So this will be 49 times 256 minus 12,544 equals to 0. And this will also be 49, negative 16 raised to the power of 2, that will also be 256 positive, minus 12,544 equals to 0. Now, 49 times 256, that will also be 12,544. So minus 12,544 equals to 0. And this will be 12,544 minus 12,544 equals to 0. So this is 0 equals to 0. 0 equals to 0. So therefore, our values for x, which is positive 16, and x negative 16, they are correct. Solving quadratic equation by extracting square roots. Our next problem, we have the quantity of a minus 6 raised to the power of 2 equals to positive 196. To solve this, we first have to extract the square roots of both sides. So to do this, we are going to raise both sides of the equation by 1 over 2. So this will be taken as one quantity. So this will be a minus 6 raised to 2. And then we are going to raise this to exponent 1 over 2. So same on the right side of the equation, we will have 196, and we are going to raise this to the power of 1 over 2. Okay, so again, since the denominator is 2 for the exponent, this will be equivalent to the square root. So we will also have here the square root. So this will be the square root of a minus 6 raised to 2, and this will be raised to the exponent of 1, which is the numerator. So we will have here 196 raised to 1. So this will be equal to, since this is 2 times 1, that would still be equal to 2. So we will have here a minus 6 raised to 2. And this will be the square root. So the square root of 196 will be, okay, so later we will write the value. But here, so let's get the square root first. The square root of the quantity of a minus 6 raised to the power of 2. So this will be equal to a minus 6. And the square root of 196 will be plus minus 14. So if we are going to get for the value of a, we need to transpose negative 6 to the other side. So we will have here two values for a. So our first value for a will be the positive 14. So we are going to use first positive 14, and if we transpose negative, this will be positive 6. So this will be our a sub 1. So our a sub 1 will be positive 20. Our a sub 2. So our a sub 2 will be negative 14, and then we will have positive 6. So our a sub 2 will be equal to negative 14 plus 6. This will give us negative 8. Okay, so this will give us negative 8. So positive 20 and negative 8. Let us check if our answers are correct. So our equation, we have the quantity of a minus 6 raised to 2 equals to 196. So for our first value of a, which is 20, so 20 minus 6 raised to 2 equals to 196. So 20 minus 6 is 14. And 14 raised to the power of 2. So we have here 14 raised to the power of 2. That will give us positive 196. So our positive 20 is correct. How about, okay, let's check the other value, which is negative 8. Okay, so let us try negative 8. So again, this will be, okay, let's change the color of that. Okay, let's change that to what? So this will be the quantity of a minus 6 raised to 2 equals to 196. So our a here will be negative 8 minus 6 raised to the power of 2 equals to 196. Now negative 8 minus 6, that is negative 14 raised to the power of 2, 196. So negative 14 raised to the power of 2, that will be equal to 196. So again, the value for x, which is negative 8, is also correct. Solving quadratic equations by extracting square roots. Our next problem, we have the quantity of b plus 8 raised to the power of 2 equals to 225. So to find for the value of b, first we need to extract the square roots of both sides of the equation. So to do this, we are going to raise both sides of the equation to 1 over 2. So this will be b plus 8 raised to the power of 2. So we are going to take that as 1 unit, and then we are going to raise it by 1 over 2. Okay, same is true on the right side. So we will have here 225, and we need to raise this to 1/2. Okay. Now, since the denominator of the two exponents is 2, this will be equal to the square root. So the square root. And then our base on the left will be the quantity of b plus 8 raised to the power of 2. And this will be raised to the exponent. Okay, so the exponent here will be the numerator. So the numerator here is 1. And we will also have here the square root of the base, which is 225. And this will also be raised to the numerator, which is 1. So raise this to 1. Now, since this is 2 multiplied by 1, that would still be 2. So this will be the square root of the quantity of b plus 8 raised to 2. And this will also be the square root of 225. Okay. Okay, so we have here the square root of b plus 8 raised to 2 equals to the square root of 225. Now, the square root of b plus 8 raised to 2, so 2 divided by 2, that would be b plus 8 now. And the square root here of 225, that will give us plus minus 15. So to solve for b, we need to transpose positive 8 to the other side. So we are going to transpose this to the other side. So we will have two values for b. Our first value for b will be, first we are going to use positive 15. Now if we transpose positive, it will change sign. This will be negative 8. So this will be our b1. So our b1 will be 15 minus 8, that will be positive 7. And for our b2, that will be negative 15 minus 8. So b2 here will be equal to negative 23. And then let us check if our answers are correct. So our equation is this b plus 8 raised to the power of 2, and that is equal to 225. So our first b, we have positive 7. So 7 plus 8 raised to the power of 2 equals to 225. So we will have here 15 raised to 2 equals to 225. 15 raised to 2, that is 225. So the first value for b, which is positive 8, which is rather positive 7, is correct. Okay. So this is correct. Let's check negative 23. So we have here b. Okay, let's erase that. So we have here b plus 8 raised to 2 equals to 225. Our b here will be negative 23 plus 8 raised to 2 equals to 225, and negative 23 plus 8, that will be negative 15 raised to 2 equals to 225. And negative 15 raised to 2, that would also be 225. So therefore, b equals to negative 23 is also correct. Solving quadratic equation by extracting square roots. Our next problem, we have x all over 50. This will be equal to 2 all over x. So to solve for the value of x, first we need to cross multiply the equation. So this means that x will be multiplied by x, so this will give us x squared. And 50 multiplied by 2, this will give us 100. So to solve for x, we need to extract the square roots. So to extract the square roots, we are going to raise both sides of the equation by 1 over 2. Now, since the denominators is the same, which is 2, this is equivalent to the square root. So we will have 2 square roots, and our base here will be x squared. Its exponent will be the numerator, and that is positive 1. So our base here will be 100. The exponent will be the numerator, which is positive 1. So x squared raised to 1, that is still x squared. So the square root of x squared will be equal to x. And the square root of 100 will be plus minus 10. Let us check if our answers are correct. So our equation will be x all over 50 equals to 2 over x. So let us first use positive 10. So 10 divided by 50, and this will be 2 divided by 10. So 10 divided by 50, that will be 1 all over 5, and this will be 1 over 5. So our x, which is positive 10, is correct. Let us now try x negative 10. So this will be negative 10 all over 50. This is equal to 2 all over 10. So this will be negative 1 over 5 and negative 1 over 5. So therefore x equals to negative 10 is also correct. And these are now our final answers for the problem solving quadratic equation by extracting the square roots.